Electric cars are taking the world by storm. Just look at what Elon Musk has done with Tesla and how the electric industry has completely blown up. So today, I'll be doing my little version of building my own Tesla. Probably Tesla's most known feature is its autopilot feature, and I've been always so interested in robotics, so I took a deep dive into learning how they actually work and what sensors are used in ensuring that when you're driving your autopilot Tesla, that you aren't going to crash into the car right in front of you. So I'm going to split this video up into 4 different sections: the components, the build, the code, and the demonstration. Okay, so my goal for this build is to build a vehicle similar to the Tesla Cybertruck of the future. I want obstacle avoidance, I want line tracking, and eventually I want geo-tracking. So set your GPS and let it go. It needs to have 4 motors, 4x4, and it must be nice, strong, and robust. So that's why I came up with this design. It's got an ultrasonic sensor, it's got line tracking at the bottom, 4 motors under the hood, quite a robust little machine, battery powered as what all Tesla and electric vehicles should be. Okay, so this is the base of the car, and I've already pre-installed the 4 different motors with their wheels. As you can see, it's a 4-wheel drive Tesla motor car, and this is all connected to a motor shield, and these information gets sent through these pins to the Arduino to activate each wheel specifically. But let's first run through the components of the brain. The most important component that runs everything is the Arduino Uno. What gets plugged into the Arduino Uno is a sensory shield. So a few basic components also: we've got an RCD. Teslas, they are battery powered, rechargeable batteries, sustainable. And then the main thing of the whole operation is the ultrasonic sensors. Think of a Tesla car. When you're busy driving and there's another car in front of you, it automatically is able to detect that there's a car in front of it, the distance is decreasing and it gets shorter. Pulsating waves are outputted, it hits another surface and it gets received on its way back. This is the robot car completely finished and all the wiring done, and as you can see, there's a whole lot of wiring to connect all the different components successfully to the Arduino. Okay, I'm about to go through the code for the build, but let me first explain the basic concept behind it. The ultrasonic sensor keeps sending out waves, it hits the object and receives it back. So it's a consistent loop running the whole time, checking where the distance is the least so that it can avoid the obstacle. We're going to have a quick run through of the code used in the obstacle avoidance section of the build. So initially we've got all the pin initializations, then we have the basic setting up of the pins for the outputs or inputs from the Arduino. So the brains behind the whole operation is the detection function, which uses the ultrasonic sensor to be able to tell the distance which an object is in front of the sensor. And you've got the 3 functions allowing the servo motor, which turns the ultrasonic sensor to turn to left, right and center, so that the ultrasonic sensor can measure the distance in front of it. Now we've got a consistent loop running, compiling the detection function, and in the detection function we're able to differentiate with the distances between left, right, center and backwards, allowing the robot car to move in the direction with the greater open space so the car can successfully avoid the obstacles in front of it. And here it is, completely built, completely wired, and it's working. I'm quite proud of it, and let's see the guy go. So here we're about to test to see if the car can successfully maneuver its way through the obstacles I placed and to see if the obstacle avoidance actually works properly. So I've placed the car so that its sensor is facing the wall, and what I'm planning to do is I'm hoping that it can successfully turn around, maneuver its way through the obstacles and get to me where I'll be standing over there. So let's get the test going. Now I'm going to be testing to see if the robot car can successfully avoid the walls in a totally enclosed area. I'm really pleased with the creation. There's a few areas where I could have improved a bit. Adding a few more ultrasonic sensors would increase the accuracy. Refining my code a little bit to make it more accurate in certain parts. In general, I think I'm pretty happy with it. Batteries run well, the LCD display is perfect. So far I'm really happy with the obstacle avoidance section of it. There's small improvements to do, but obviously for first time, I'm quite happy. I've always been interested in robotics and seeing the new creations and gadgets being developed and invented every day, and seeing the electric industry completely boomed. I thought I have to get involved and make my own little creation, my own little gadget robot car. If you guys enjoyed this video, I'm hoping to one day keep on improving on this vehicle, hopefully get it into a form where I can call it my own little Tesla, where it can geotag me and drive towards me while avoiding obstacles in the way. So that's the plan, that's the goal. Get a bit of a bigger motor, get a nice proper frame so you don't see all these wiring, and maybe get a few more sensors so that it's accurate and faster. If you're still watching at this point, I just want to say thank you very much. I really do appreciate your support. If you've enjoyed it, please give it a thumbs up, give it a like, it really helps with the algorithm. And otherwise, subscribe to catch the next video on Thursday. If you'd like to get yourself a kit so that you can build your own robot car, I'd leave a link in the description. And also if you're interested in seeing the sample code, I'll also leave a link in the description so you can make it yourself.